Did we get the transition right this time? Hey, there it is. Good morning, good afternoon, good evening, whatever time it might be where you are out there. Welcome back to the live stream. My name is Jeff Fritz, and this is Learn C# with CSharpFritz. How you doing there? This is, of course, a session. This is a very much scripted session with AMA capabilities. Ask me anything you'd like about C#, where we're going to learn more about C#. We're going to learn more about the programming language and hopefully get you some answers and get some discussion around some features, some things that are going to hopefully make you a better developer. Thank you so much, friends, for dialing in. I'm seeing all the folks over here in the chat room. Let me bring up the chat rooms. They're over here. It's a full house over on the chat room today. Oh my goodness. Look at all these folks. Because we're broadcasting to Learn TV, YouTube, and Twitch. So if you're watching on any of those services, it's so good to see you. Thank you. Folks from YouTube and Twitch will answer your questions right here in the chat room. Let me say hello to some of the folks that are here. My goodness. Look at them all. Look at all the chat. I'm going to start over here on YouTube, and I'm going to start with Greg Cyrus. Good to see you. DJ Curry Synth. Howdy, howdy. Christian Rodriguez. Hello to you. Daniel Case is dialed in from Essex in the UK. Nika, hello, hello. Carlos, good morning to you. Mahalis, is this streaming on Twitch as well? Yes, and I shared a link. There you go. I'll be Hacks, hello. Good to see you. Kasoon, welcome. Is that Dooch? Duke? Hello, hello. Let me see here. Yeah, let's do this. Moosey from India. Ladybug, good to have you back here. Let me say hello to some of the folks over on Twitch. Chris Jones is here. How's it going? Crypto Yanni. Hello. Good morning. Good afternoon. Eggsy's here. How's it going? Scrolling through here. Flying Rossellini. Bojan is here. Hope everybody's having a great day. Olatoni from Nigeria. Welcome in. Just Ray is a fish. I thought you were just Ray, though, but you're a fish. Mr. Joe B, how's it going? Got your coffee ready for another C# session? Great to see you, Mr. Joe B. Hello. You like the hat? You like the Xbox hat? Right. I'm staying in Microsoft theme here. It's not explicitly Visual Studio or C# or Windows. It's Xbox today, right? Like, got to bounce around to different things. I've been looking for a Bing hat. Haven't found one. Need to find a Bing hat. There's got to be, somebody's got to have a Bing hat. You like the shirt? NASA shirt today? Hello to Kevin in the Dominican Republic. Good to see you. Bao, is it Bao Luchtong? Good evening to you. Let me see here. Surge Dev is here. Zofran777. Where can you find info on setting up using the notebooks? It's all right in the GitHub repository. If you head out to github.com/CSharpFritz/C# with CSharpFritz. If you're watching on YouTube, the link is in the description just below. There it is in chat for anybody that's going through and following from there. Jay Frey, hello to you in Switzerland. Richard is here. Hello. Yeah, the whole world is here. My goodness. Oxtari in Cyprus. Rupesh in Nepal. My goodness. It is so good to see everybody. Is that Ijiba from Senegal? Let me know. Nakil in India. Hello. Gregory White in Ireland. There we go. We got an Irish fella in here. Carlos Barbosa grabbing a coffee. Marcus in Sweden. I think I mentioned that. Jay Frey. John. I'm not sure how to pronounce the rest of your handle there. Hello to you in Connecticut. Okay. That's a fine factoid about AWS there. Thanks so much. Tron is here from Vietnam. Tran? Is that I think it's usually pronounced Tran, isn't it? Let me know. Marius, thank you for the great C# lessons. Thank you for tuning in. Appreciate everybody who tunes in and is watching. Nurulu Lee Loy from Vietnam is here. Would a duck hat be close enough? See, it's a branding thing. Can't quite do that. Burger B, hello, hello. Let's see. Lurchikas from Florida. Hello, Cigar. Mohammed, I should Google for a Bing hat. I see what you did there. Mohammed. Chaitanya, hello. Otto, Microsoft NASA acquisition leaked. It doesn't work like that. It doesn't work like that. Fernando in Brazil, hello. Tomahawk, I see you're doing something there. Your Visual Studio 2019 is not stable, often crashes. Do a repair on that. Something else is going on there on your machine. How you doing there, Otto? RWP1 Byte from Indonesia. A couple folks from India, Chaitanya, Sarvesh. Blask 1967 from Germany. Do I wear these glasses the whole day? I wear them a lot of the day when I'm working on a computer. These are Gunnar glasses. They're designed to help with blocking blue light and keeping my eyes from getting tired from it. When I was on the Hello World show, you've seen the Hello World show. It's over there on Learn TV. And you can find the Hello World episode that I was on. It's over on YouTube. When I was on last week, I didn't wear the glasses all day. I had been busy Tuesday evening and it right through into the evening. Went downstairs to get dinner, realized I still had them on, took them off and left them in the kitchen. And the next day I completely forgot about them. I got done that Hello World show and I had a headache like you wouldn't believe. So I found that these are, for me, very helpful. Poncho, hello to you in the Netherlands. I like what you did there, the task from result. I didn't write any samples with the from result stuff. Might need to cover that. Favorite design patterns. Love the repository pattern there, Nick. SZZBDD, good morning to you in Michigan. Pedro is in Brazil. You learned and used mutex. Not going to be talking on mutexes and some of those other multi-threaded helpers. We're just going to be talking about async, await, task, and we're going to get into parallel for each today. Nur is in Kazakhstan. Do I plan an advanced course? Advanced is all is certainly a question. I think there's an opportunity to bring on some of the C# team members and go a little bit deeper on some of the topics. It's not a bad idea. Let me think about it. Nikhil, good morning to you in India. Actually, it's probably good evening to you. Aquarist123 in England. Hello to you, Farad in the Ukraine. What's the Twitch URL? Twitch TV/Visual Studio. Jack is in Turkey. Is it Clincy in Kosovo? Mark, hello to you in Russia. Another Senegalese. Oh my goodness, so many folks today. This is great. Just Ray asks, is async await a programming style that makes use of multi-threading more efficiently? Yes, and we're going to talk about that. We're going to see some concrete examples here. Miss 1013374, because 1013373 and earlier they were all taken. Greetings to you in Germany. Hello, hello. Harvey's in Clearwater. Sammy's in Tunisian working in Germany. Oh my goodness. What time are we starting? We're going to get started here in just a minute. I want to make sure I welcome everybody in, say hello. It's the least I could do to help out with folks over here that are acknowledging you and welcoming you in, because it's important to me that you know I'm reading every chat message. I want you to know that this isn't just a presentation. If you want to watch a presentation, you want to learn some of these topics, sure, go out, search for the YouTube video, you can watch it, and in 15 minutes, you're going to learn all of C# in 15 minutes. Right. This is about the discussion. This is about getting involved in helping you out that's watching out there at home or in your office or wherever you might be. If you're watching the recording, I hope you pick up, and I hope some of the questions asked by the folks in chat that we get to today apply to your scenario, whatever it might be, and we go through and we answer and work with your type of scenario. Of course, I'm going to review questions that come in comments that are just below the YouTube video on the recording if you are watching this recorded sometime in the future. And if it is the future when you're watching this, hello, future people. So good to see you. Let me know who wins the Super Bowl so I can place a bet on it, and we'll do this whole back in time thing, and maybe we'll win a couple bucks. Does that work like that? I saw that in a movie once. Let me know. Onar, good. Hello to you in Turkey. Update to the 2022 preview. Yeah, Visual Studio 2022 is coming soon. In case you missed it, Visual Studio 2022, we announced that it's going to be released. There will be a release event that you can tune into on Monday, November 8th. It'll be on visualstudio.com. I think that's where they're broadcasting it. But it's the same week as .NET Conf. So the 8th, you're going to be able to see the launch of Visual Studio 2022. One day later, you'll see the launch of .NET 6 and .NET Conf. 80 sessions for .NET Conf. Broadcast and brought to you from folks all around the world. 6 of the 7 continents represented. Sorry, Antarctica. And folks talking about all kinds of different .NET topics. I hope you tune in. .NET Conf is November 9th through the 11th, including 24 hours straight from the 10th through to the 11th. Actually, 32 hours straight because we start at, I think it's 9 a.m. 9 a.m. Pacific time on the 10th, and we go right through to 5 p.m. Pacific time on the 11th. There'll be something broadcast from somebody from your part of the world in your time zone. So I hope you tune in. It's a really great event that we really enjoy. You're having headaches with too much screen time, Burger B says over there on Twitch. I got to catch up here. Chai Tiana asks, am I done migrating to RavenDB? I ran into a couple of data consistency issues. My data types weren't all the same. I had date times in a field, and sometimes they were date time offsets. And it was getting confused when I was building indexes, and some of my data wasn't quite accurate there. So I had to go through and update a couple million records appropriately. And that took a really long time. I think I'm there with my migration. I'll let you know before tomorrow's stream. Advanced course in how to tame task creation options. Yeah, there's some deeper content there that we're not going to get into today, but we definitely should talk about. Am I going to be covering cases for ConfigureAwait false? Yes, that is something that we get a lot of questions about. I'm going to cover it briefly because, quite frankly, for beginners, you shouldn't be calling ConfigureAwait false, period. You shouldn't be doing that. Let the framework figure it out, and I'm going to show you exactly how it works, why you would want to call ConfigureAwait, why you wouldn't want to call ConfigureAwait. We're going to get there a little bit later in the stream. Good morning to you, Winterfell in Fort Lauderdale. Dipta is on their way to learning C#. Till now, I know object-oriented programming concepts. Do I need any special prerequisites? You can go back and watch other videos in this series on YouTube. Go to the .NET channel. Click into the playlist Learn C# with CSharpFritz, and I'll walk you through the basics. I believe in chat you can let Dipta know what you think of the series here. I think we've been pretty good. There might be some things we could have done a little bit better, but I'm kind of proud of what we've accomplished. Ehsan, good afternoon to you in Iran. I'm going to skip through a couple folks here. Keith Ernett, hello to you in Huntsville. Osman in the UK, hello. Can I talk about parallel task async? We are going to talk about parallel for each. Spooky Coders in Austria, not Australia. Sodiq in Qatar, great to see you. Amal. Arshia, hello. No, sorry, the hat bot does not run here. If you go over and watch my show over on Twitch, on Tuesdays and Thursdays, I have a AI that sits in chat and will tell you what hat I'm running. I'm doing well today. Diego's in Brazil. I'm going to skip through a couple of these. Task versus thread. I'm not even going to recommend or get into thread today. We recommend everybody uses task now. Task await all versus parallel for each. We're going to task when all, and I'm going to show both of those. Locking on concurrent objects. Not going to talk about that. Sorry. Talking strictly about tasks and how to get that running. Those concerns around interacting with locks and concurrent objects a little bit further down we're not going to get to today. Repository pattern is great. Using Onion architecture, fantastic. Rizwan is here from 2025. Dude, let me know what's going on in 2025. Are we all on like hoverboards and flying cars and stuff? That's pretty cool. Good afternoon, Jens. Good to see you. 99% of the time, it works every time. Yes, and we're going to talk about that as well. The concepts from basics. Yep, we're going to talk about that. Would I cover async enumerable? No, sorry, it's a little bit further down. GitHub or GitLab? I work for Microsoft. GitHub. That said, I have a GitLab server installed here in the home on my home server. So nothing wrong with using both. But when it comes to building and deploying with enterprise trusted environments, GitHub. Good afternoon to you, Nitro Evil. How's it going there? _ how do you become a C# MVP? You need to be nominated to become an MVP. Somebody who's either in the MVP program or a Microsoft employee needs to nominate you. Check it out at mvp.microsoft.com. How's it going there, UNESCO? Good to see you. Wayne, hello. Good morning to you in California. You're following that series, Dip Dip? Fantastic. Is Task a high-level implementation of Thread or something else? Something else. Well, it's an abstraction over threading and asynchronous processing. You're going to see more about that in a bit. Herbert, good to see you in Taiwan. Why .NET does not have async events? Events by their very nature are asynchronous. So you don't need to call async on it because they're being triggered from another thread somewhere else. Yvonne, hello to you in Peru. Terry's dialing in from the Carolinas. Johnny B. Cat is here, waiting for the GitHub versus Azure DevOps shakedown. It's a good question. Jens is here from Australia. Good evening to you. Whew. All right, we've been through the entire list of chat messages. My goodness, so much going on there. Thank you so much, everybody that's tuning in. Let me get some music playing here in the background. This is, of course, Stream Beats from Harris Heller. I'm going to be playing the Synthwave playlist today. This is music that's designed to be royalty-free, DMCA-free. You don't have to worry about anybody chasing you down, like the Cobra Kai, the Skeletons, and the Karate Kid, anything like that. All of this is available free, no royalties needed. You can stream on your favorite platform with it, and you can get access to playlists for Amazon Music, Apple Music, and Spotify. Check it out at streambeats.com. Thank you so much to Harris Heller for making this music available for us today. Why is chat so chatty? Eggsy, because this is a fun topic today, talking about multi-threading and getting more out of your processor. And yeah, all those cores that you've bought and you've installed. Can we find somewhere the past streams? Yes, check it out, youtube.com/.net. There's a playlist there called C# with CSharpFritz. You can click in there and you'll see more of these scripted videos. My channel, you can find on youtube.com/CSharpFritz, and I cover all kinds of different topics over there. We've been bouncing around on a bunch of different things. Dimitri who asks, is it safe to run async tasks in infinite loops? Yes. Considering the app does not get reset like an IIS. Yes, it is. You're going to want to be able to cancel those. We're going to talk about cancellation tokens today there as well. Operating system is more than just threads, I/O completion ports, file handles. Yes, exactly, Mammut. Async await is a higher level concept that abstracts away all of that, so that all that you as a .NET developer have to think about is just wait for this thing to get done. It's going to fire, and we'll see what happens when it comes back. Samuel, hello to you in Brazil. Hello, is that Kumbaka? In Indonesia. Hello. You've been a software developer for decades, but I still find async await a challenge. Totally agree. This is not a simple concept. Let's start with that. Let's start with the concepts we're going to get into today are around asynchronous programming and multi-threading. Those are two different things. And they're a little bit further off. Everything that we've been doing to this point has been synchronous programming. That is, code progresses from the first line that you pass in to the next, to the next, to the next, synchronously in order, okay? When we think about asynchronous processing, that means that things kind of bounce around and happen in different order. And when we think about multi-threading, and asynchronous processing, we'll see how you'll call out, it'll go do some things, and eventually it'll call back and continue and pick up where it left off. Multi-threading is a way for you to send tasks, for you to send different programming instructions to be executed on different threads. So when you execute things synchronously, they start on a thread, right? There's the processor. Our computer wakes up and says, I'm going to start executing these commands. And it's executing things on the same thread, right? There's a dedicated line of processing that's reading through, and it's all in the same memory space and consecutively executing that code. Multi-threading is a way for us to say, give me a couple of those. And we're going to send some tasks over here to that thread. And we're going to send some over there to that thread. And I'm going to coordinate, and when everything's done, do something else. But maybe I want to do some things while those are processing. And that's multi-threading. Now, asynchronous code can behave multi-threaded like, because you're going to call off and say, go do that thing over there. And while that's happening, I'm going to do some other code over here. And we'll see some samples around that in just a little bit here. Is task inherently async await? It is not. We'll talk about what task is in just a minute, okay? But a task is a wrapper around these concepts that async and await deliver to us. We'll talk about that in a little bit. Reef is having trouble explaining to their colleagues async await and multi-threading. Let's talk about that. They believe async await is multi-threading, and it is a common misconception. Async await can be multi-threaded. It isn't by definition multi-threaded. You're going to say, let me explain that in a little bit with some concrete examples when we get over to the full set. Debugging async is a pain. Yes, Nitro Evil, it is. Debugging asynchronous code can be difficult because your call stack gets tossed up into the wind here. Hello to you, Alejandro in the Dominican. Vitor in Quebec. Good to see you. Wait, Quebec. Make sure I say that right. Like the way the GPU works. Yes. A little bit like how the GPU works. How's it going? The S4P0. Good to see you. Can we say that async is kind of line jumps in assembly level programming? Kind of. Not quite. Kind of. It's close. A bit on value task would be great. I didn't want to get into value task. I didn't want to get into value task. I'll try to get into a little bit if I remember later, but it's a little bit further along. That's right. It is VM level, but making a comparison, not saying it is assembly level there, Jin, but it's to compare it, not saying that it is, but using a metaphor. Hello to you, Fred in Ghana. It is a code gen trick. That's right, Iminson. It is. Yeah, it's similar in concept, not quite this. It's not implemented the same. It is a code generation trick that we're using. So, how's it going there, Aditha? Adithia? Jorge says Chile is present too. Fantastic. Hey there, what's up, baby? Okay. So I got a new piece of hardware over the weekend, and I'm kind of thrilled. I bought it specifically for this show. You may have seen me when I'm reading chat. I'm always doing this, looking at my confidence monitor. So I got my hands on a teleprompter so that I can put chat room right in front of my camera. So when I get over to the other set, which is right back there. See? When I get back over there, you'll see I'll be reading chat directly off of the camera. So I believe this will be a better level of engagement because when I'm reading your messages, I'll be looking right at you. So I hope that isn't creepy, but I think it'll work. How to handle situations when I don't want to wait for code execution inside an async method. Is there a good way to create a fire and forget scenario? Yes, I will show you that. I've got great examples of that coming up here. How safe is asynchronous link processing inside an async task inside a parallel for each? It's not. Parallel for each and then async processing down the line like that, it's not. I think async is like making a breakfast, like a 200 series of learning C# in the .NET channel. We're going to look at the breakfast example, and yeah. What's the difference between asynchronous programming and synchronous programming? Nikhil, we're going to see that in just a little bit as well. That I've already got that loaded up here. That's president level hardware. Cool. Hey, look at that. What am I doing when my stack traces stop at move next? I don't know. Good evening to you, Sharaf in Egypt. All right. We've said hello. We've welcomed in. We've answered a couple questions. We've gone through a little bit of chit-chat. We're about a half hour in. Let's go get set up over on the code, and let's start talking about our code, what we're going to work through today, and getting a little bit further on the async await. So if I've done this right, I'm actually going to look proper when I get over to the other set. Ah, rats. Ah, there we go. There we go. I had run over my headphone cable. Test. There we go. I'm over on the other headphones. Are paradigms used in synchronous programming the same as async programming? Kind of. Yes. All right. Let me head over to the other set, and let's get things all queued up here and have a little bit of fun with this. So I'm going to go get in the code. Heading over to the other set, doing the thing, walking over. Here I am. Oh, no! Yeah. There we go. Fantastic. And it worked just the way I wanted it to. Feels so good. We're going to talk about that in a little bit. Back over here. And let me clear all the outputs. Right over there. Async await and multi-threading. Let me see. I should be able to control. There we go. Can I show out multi-threading debugging tips? No, I am not going to be able to get into that today. What's the difference between async await and promise? Is there a promise equivalent in C#? Kind of. That's what a task is, and you'll see a little bit about that. The difference is the same as MS-DOS and MS-Windows. What? Yeah. Ubuntober? No, Ubuntober. No. Well, I mean, we're continuing in it, yes, but we're going to be over here. Much crisper sound. I don't. So the other one is a dynamic mic, where this is a compression mic. So that other one shields out and doesn't pick up all the lows and highs, and then it gets compressed again. Is concurrency different from parallel? No, you're on the same line. Yes, Ubuntober on the Visual Studio channel. We're here. We're live using Linux. I want to make sure that you're comfortable, that you know and you're aware that Linux, Mac, Windows, they're all very welcome to be using .NET, to be using C#. It's a great way for you to be happy and be able to program your favorite programming language wherever you want to be. All right. Somebody was saying they really like Visual Basic. Yeah. I like Visual Basic too, but C# is really where it's at and where you need to be. Slow Sunset Vibes asks, is a task the same thing as a thread? No. I'm going to talk about what a task is in just a minute, all right? So let's talk about what async await and multi-threading is. I still haven't mounted the monitor over there so I can read everything while I'm coding here. So as part of the .NET ecosystem, of course, we're programming with C#. We've got full access to work on our machine, and we want to be able to take advantage of all the resources on our machine. That means connecting across the network, accessing disk, accessing other sensors and things that are on our machine that we may want to interact with. And, well, on modern machines, you've got a lot of cores on that processor. You want to use more of that. You want to be able to spread out that workload, especially if you have computational intensive tasks. Spread that out so that it's not blocking what the rest of our user is doing, right? Our users are allowed to interact with the user interface, and other things are going on in the background. A great example of this, if you're using Microsoft Outlook, you can go into Task Manager and you can see exactly how many threads Outlook is using, and it's always using a lot. Why? Because it's refreshing all the data for your email box and your calendars and all those things in the background while you're typing your email, scheduling a meeting, doing all those things. And we need to be able to juggle all of that so that you get a crisp experience and it feels like everything is running live, when in fact there's other things going on in the background that are updating what's going on. You see this also with browsers, where the browsers are going and updating and painting different things on the screen as you're interacting with that. So, let's see. Missing on error resume next in C#. Why? Why would you want that? No. We talked about error handling actually last stream. So, now, since C#1, there's been ways for you to run code asynchronously or with multiple threads. I'm not going to get into those techniques because, quite frankly, we don't recommend that you use them, because you're going to potentially run into errors, scenarios that are going to trip you up. Hello to you. Is that Otseal in South Africa? No worries about being late. That's okay. There's a rewind button on YouTube. So, we recommend folks use these new keywords that have been made available for about the last 10, 13 years, called async and await. Now, what async and await allow you to do is interact, and check out, I've actually written it right here. It's like I planned this or something. So, move the little hand thing, Fritz. Come on. There we go. So, this benefits greatly for I/O-bound and CPU-bound code. So you've got a lot of code, you're going through doing a lot of calculations, and you need to wait for that to be done, or you're requesting something over the network, you're interacting on disk, you need to wait until that network request finishes. A database request completes across the network and delivers you the results. You're interacting on disk, you can't continue processing until that interaction with disk, reading a file, writing a file, has completed. You want to make appropriate use of your resources so that when it comes back, you're ready to pick up and continue working, and you're not blocking other things from happening on your application. So, async code uses task of type T and a task object as a return type. It allows you to model the work being completed in the background. So this is a little bit like a promise, okay? The task tells you, is it completed? Has it been canceled? And it gives you a handle that you can also wait for and say, okay, wait until that thing is done. I can also say, when it's done, continue with and go do something else. So the task is very important for us to be able to have that pointer to what's going on in the background. The async keyword turns a method into an asynchronous method, which allows you then to use the await keyword in its body. So this is an asynchronous method, do these things, await for some other process to occur, and continue processing after that. So when the await keyword is used, it suspends the calling method. It stops it, okay? Yields control back to the caller and says, go ahead, you can go do something else, while the awaited method completes. We'll see how that works in just a second. So you end up with this, go do something, hey caller, you can go and continue doing whatever it was that you were doing. I'm going to notify you when I'm ready to continue processing and pick up and continue. The await keyword can only be used inside of an async method. This is important. You can only use it in an async method. So if you have synchronous methods, we're going to need to play some tricks to get it to continue working. All right, let me see what else is going on. I see some folks in chat. I'm not talking about observable collections today. Sorry. Perfect example of synchronous something using a single thread is the old command prompt. Yes, that's fine. Absolutely. Does this mean async await in .NET has to use task return type? It doesn't have to use the task return type. You should use the task return type so that you can process and handle it properly. Similar to how Node.js works? Not quite. But it's similar in concept. Does every async function return a task of T-type? It should, so that you have some concept as to what the method is doing. You don't have to. I'm using a loop to call a task that cannot be called again until it finishes. What's the best way to do this? Yeah. I would return a pointer to that task and do a await when all. And we'll see await when all in a minute. Is it an anti-pattern to use async awaits when maintaining legacy code that was not initially async awaits? I wouldn't call it an anti-pattern. But I would say it's an unneeded optimization that you don't necessarily need to do. All right, let's get into let's get into this a little bit and talk about how and when we use these. First off, let's talk about why you would choose something that's CPU bound and IO bound and the different ways to handle that. If your code will be waiting something from disk or across a network or some sensor, there's another piece of hardware at play, not the processor, some other piece of hardware, the GPU, a sensor or something that's running GPS sensor, right? Those types of things are IO bound. Okay, input, output. You're waiting for something else to finish, not this processor, not this application. It's IO bound. If your code inside your application is going to be performing that expensive computation, right? You're going to calculate pi to how many digits. That's CPU bound. You're going to calculate prime numbers. We've got a sample showing that today. That's CPU bound. All right. So let's start off talking about IO bound examples, like getting data from the network. All right. I'm going to take a quick look at chat here. Can C# do multi-threading on the GPU using CUDA? Yes. I'm not going to get into using CUDA today. It's a different library that you can use to delegate tasks to be used on the GPU, but you can absolutely do that. All right, so if we want to get data from across the network, we clearly want to wait for that to return. So I've got a little method here. I'm using the HTTP client. This is native to .NET. I had to put a using statement up here so that I could get into the appropriate namespace where it's located. So I'm going to use my new HTTP client here, and I wrote a little method, getAsync, and I'm going to go get some URL. So here, right, this is an async method returning a task of type string. This is the typical syntax you will see for asynchronous methods. This is going to run asynchronously, and it's going to wait for us to go get that URL. Clearly, reaching across the network, we're going to make that initial call. We're going to wait for a server to respond. We want to wait for all the data to be delivered on that request to our client, and then return control to the calling process. So go get all that data, and when it's done getting the data, right, so await until it's done getting that data, put it in this response object. Now the response object has a bunch of properties on it, but particularly we're going to go grab the content of the response. We can also grab things like headers and the return type, right, the HTTP code, but we're going to go get that content. We're going to say, you know what? Read the content as a string, but read it asynchronously. Once again, This is CPU bound here because the string is on our machine, but it's going to be a really big string. We want to load all that up and deliver it into whatever variable is calling this. We're going to return that as that string right there. So I can write a very simple method here that says await, go get async ... .net. Get me the contents of the .net website. And when I run that, you see it takes a few seconds, and eventually it finishes, and we see the HTML for the .net website. And it stops there in the notebook and says, okay, there's more content. I'm going to just omit it here. We can take that out and look at it later. So I've fetched data, and I've returned it, and it looks like for the purposes of any other program that we've written, it looked like it was a synchronous program. Even though things were yielded and things were awaited here, it was handed off and other threads did that, came back, and our thread continued. And quite frankly, I don't care about those other threads. Go do your other thing over there. Return to me as quickly as possible. All right? Now, let me take a look back at chat and make sure that I'm caught up here. What's the best way to get the top n tasks of an array of tasks and stop awaiting others? Too specific. I'm not going to answer that question. Drop me a line on the YouTube comments, and we can take a look at that later. Sorry, that's way too specific an example. The display has the await keyword, though it's outside the async function. Correct. So what I'm doing here, right, I'm calling get async, and I'm awaiting the response. So think of this as a single unit of method call. Right? Let me move that up just a smidge. Think of that as a single unit of a method call that's saying execute this and await it coming back. This way, right, I'm telling it exactly how to handle the threading, how to handle the response that comes back, and I'm saying display it all right here when it gets done and returns. What's up, baby asks, should I use .NET 5? .NET 5 is our current release of .NET, our current production version. .NET 6 is going to be released in less than 4 weeks. 3 weeks. 3 weeks? So you should be able to get started with .NET 5, and I would then strongly consider moving to .NET 6 as soon as it comes out in November. Displays the caller, that's right. On line 7, if we skip the await keyword, what would happen? Spoiler alert, that's where we're going to go next. Can you have async properties? No. Can you call async methods from properties? No. You have to convert those to be synchronous. If I want to call get async method in the example, should I add await if I would like to wait for the response? Yes. Absolutely. Let me show you that in a little bit. I'm going to get into ConfigureAwait. Hold on to that. We're going to get back to it. How is it an async method when we immediately await for the answer and runtime wait for it? It's async because it's happening on another thread. It's yielding the thread in case there's other things we want to do. The async and the await are an abstraction over asynchronous and multi-threaded processing. If it happens fast enough, it comes back immediately and there are no additional threads or things in use. But if it takes longer, it will yield the thread and allow you to do other processing. So the response variable is not just a user-created variable. The response is not a user-created variable here. The response is the content, the response from the get method, right? It's telling me here's all the content and information about what the HTTP server responded. What's the best approach to fire and forget? I'll show you that in a little bit. A lot of folks jumping ahead here. Okay, so let me scroll down to the next example I have here. There's the explanation talking about this. Now, asking, well, how do I fire and forget? How do I do some of these other things? So you can execute the method and not call it with the await. In this case, the .NET variable is not the response, but is the task. Because we haven't awaited, we haven't told the task, let me know when this is done. When you say await on a task, the result that you get back is whatever that result is on the task. So I'm then able to inspect the task and say, well, is this completed? And I can interact with it. I can say, well, wait for it to complete by calling the wait method there. And I can display that result object by calling .result and execute. So I immediately get a response. Is it completed? False. It's out there executing. I then called wait. So I wait for it to complete, and then I get the result. So I haven't... I've fired and I've remembered the task. That's important, that I remember the task. And I'm coming back and saying, well, wait a little bit. In fact, I can copy this display down to here. Is it completed immediately? No, it's not. I waited till it's done. Yes, it is completed, and I'm displaying then the result. Here's what it is. Now to the question of fire and forget. If I don't store that .NET task there, your code that is running on that asynchronous method could be garbage collected and cleaned up. So it's important to grab and maintain a pointer to it. And that's what the task is. Our task is a pointer that says, here's the process that's going on. Here's all the information about it, so that we can inspect and see what's happening. We can figure out, has it been canceled? Has there been an exception thrown? What's the state of it? Is it completed? Wait for it to finish. All these things that you may want to know about that process you just kicked off. I think it's Alt Delete to hide it. There we go. All right. Let me take a look back at chat. Catch up with some other messages here. What's the reason for having no asynchronous properties? Properties should respond immediately. You're inspecting something. If you're going to get something that needs to run asynchronously, that's a method. Wait, is something like a semaphore? No. No. What are the possible problems running an async method with Entity Framework? You shouldn't have any problems running async methods in Entity Framework. Those async methods in Entity Framework should respond when you've got data available. So they will implicitly return task of type T? No, you need to explicitly declare task of type T in your async functions, like I did there. Task of type string. Move that. There we go. You need to explicitly declare you're returning that, so that your C# methods that call this know how to respond, how to interact with that. What's the point of wait? Well, if you're firing a task and you want to wait for it to complete, you call wait, or you call await in front of that task, and it returns immediately. So line 1 starts the async process, but line 3, let me go back to here. Line 3 says, okay, block and wait for it to be completely executed. That's right. Yep. Be MOSBAT. That's right. Does multithreading happen in processor or main memory? Well, it happens on the processor. You're going to allocate things in memory. Will this live video delete after I finish? No, it'll be persisted on the Learn C# with CSharpFritz playlist on YouTube. The wait prefix is pretty much just doing the .NET await. That's correct. Yep. I've heard async await is not actually a different thread. That's right. It's not actually, but it is. It's an abstraction over it. You're not necessarily on the same thread. We'll talk about that. Is there a way to create a task and evoke it somewhere else? Yes. So we've right? Where we have this task that we've been handed, and it's actually already processing, right? You can create a new task and pass that around. It's a little bit further along than I want to get today. Continuing here. In which scenarios we should not use async and await when you need to do something synchronous? When is it advisable to use wait compared to await? You want to use .wait when you need when you're passing the reference to that task around and you need to inspect that task. Otherwise, use await. No, it does not implicitly return type task. var.net does not return type task. There is no implicit with tasks. You must explicitly declare that you're returning tasks. Tasks are never implicitly used in C#. A print task to a network printer, fire and forget. Yes, but you need to keep track of that print task, because if something happens to that printer, paper jam, right? The printer is offline. You sent that command to the printer. Well, what happens if there's an error? You need to keep track of that so you can report back, hey, there was a problem, there was a mistake. We need to process that. Why use await when you want to use the response from the asynchronous process? Well, right. Yeah, yes, you only use await. That's correct. And you don't need to inspect and get into and do things a little bit out of process here. What's the point in using async await in server-side code? There is no UI in comparison to blocking calls. Just inefficiency of operating system threads? No, think about it. If you're building in a website, the web server only has so many threads. So while you're waiting for data to come back from your database or from a microservice, yield that thread so that another request can be handled. Yield that thread, go finish, let the database or the microservice finish. When it's done, pick back up and send the response to the completed response to whoever called the web server. So, can you get inconsistent results mixing async and sync calls? That's a very... I don't know your scenario. It's always possible to have inconsistent results. Okay. I'm going to continue on here. So we showed without that we get the task back that we're then able to interact with. Now, we can do things then. We can fire multiple async operations, like you would if you had 2 tabs in your browser, right? Let's go get on one tab, let's go get bing.com. On the other tab, let's go get .net. See what I've done here? See, this is me continuing the Microsoft branding properly. See what I did there? I could make this Minecraft.com, but looks good. All right. So I'm going to say go get those 2, but notice I'm not awaiting them. So that means when I look at the Bing variable over here, it's a task. When I look at the .net variable over here, it's a task also. I can then use this whenAll method to say await for all of those tasks to complete and then continue processing. So await blocks at this point. It says go finish what you're doing there, release the thread, go do something else. I'll tell you when I'm done, processor, so that you can pick right up on the next line after this. Okay? So wait for both of these to say they're finished and then continue processing. And you can pass in any number of tasks there, not just a comma-separated list. You can pass in a collection of tasks there to say, well, when all of these are done, continue processing. So when they're all done, then I'm going to display, here's the Bing HTML length, here's the .NET HTML length, and I'll say the total elapsed milliseconds for those requests. And it was, well, it says right there, 1.2 seconds, but it was 1,228 milliseconds. Now, if I did those consecutively, if I had done a wait here like this, right? it's going to run the first fetch out to go get Bing. Then it's going to run the fetch to go get it from the .NET website. And here, I'm not inspecting the result anymore. I have the result because I awaited. So if I run it that way now, all right, see now, because of caching, I look like I'm lying. It's at 0.7 seconds. Let me turn that back. I should have run it a second time when it was in the previous model. Should have run it a second time, otherwise the demo looks kind of cheesy. I knew that. And I knew that. Because when I was testing this, I was like, wow, that's really fast. There we go. So now when they're run asynchronously, I get it in less than 0.4 of a second. It doubles in speed because it's running both queries to both websites at the same time, and it's only returning control to say continue here when it's done requesting both of them. There's other methods that you can take a look at here to help with some of that concurrency management when any. So I can say, well, when any of these are done, continue processing. Okay? So I'm going to do when all there. So that kind of works out. Let me take a look back here at chat and catch up here. Does async await work the same as JavaScript's async await with event loop? I believe so. And right here, you're seeing the cross-pollination of programming languages where C# developed this feature as a shortcut for asynchronous processing way back in 2008. And just now, but not just now, but right, it's making it its way into other programming languages. Will there be a replay? It's recorded and will be available on YouTube later. youtube.com/.net. How to handle concurrency? Not going to get into concurrency. I'm sorry. That's a little bit further down. Continuing. Wait versus get and awaited get result. Right. That's exactly what you just saw there. Does the wait need to be in an async method? No, the wait needs to be on a it needs to be run on a task though. So, does this when all block the main thread? No, it doesn't. The await releases that thread and comes back. I could do task when all dot wait. And move. Yeah. Right? And it comes back that way. All right? So I'm awaiting all of that, and I'm calling dot wait to say, well, just wait until it's done. That blocks the thread. Calling wait blocks the thread. Calling await releases control, so you still get some responsiveness, and then comes back when it's done. Yes, we're going to look at parallel for each in just a little bit. So yeah, caching bit me there, didn't it? If the async method waits for a response, is the same behavior of an async method, isn't it? It feels like, Jeremy, it feels like the same behavior as a sync method. And to developers, it makes writing those asynchronous interactions so much simpler, right? It looks and feels like an asynchronous method, like a synchronous method, like your normal coding, which is exactly what the language designers wanted. You're getting better performance, better use of your hardware without having to go and handle, we'll start up a thread and run this asynchronously. Here's the callback method to call back to so it knows how to continue. There's a lot of back and forth code that happens there that's all being hidden from you. The language is delivering that feature for you without you having to do all of that work. C# got inspired by JavaScript, Kappa? Yeah, the other way around. JavaScript features have now been significantly inspired by C#, thanks in part to TypeScript. Is this the same as parallelism? Not yet. What you're seeing here, these aren't necessarily parallel tasks. They're two asynchronous methods that are being called at the same time. So I guess in that sense they are parallel. it's not explicitly parallel, and we'll see more parallel later. Does task wait block the calling thread? Yes, it does. Answered that. Hey, 3D Polywraith. Hello, hello. All right. What's this? Async await best practices. Yeah, there's a whole bunch of discussion out there, and we're going to get into more. And I've got some links to that as well. What if a task takes too long? You can cancel tasks. I'll show you that shortly as well. So, task object. Right, I mentioned and blah, blah, blah. You can read this. But we can also say continue with. So when you execute continue with, right? So here I've got get async. And, right, so go get .net and then continue with, here's the next thing to do. Now, right, this is going to run asynchronously in the background, but because I'm not awaiting it, I'm getting a task coming back, right? If I mouse over this, there it is. It's a task that's being returned, but I've chained on to that task and said, do this thing next. I'm going to display task is completed, and here's the length of the HTML that I fetched from the .net website. I'm then going to display checking .net complete state, and then await the .net task. So we're going to first set up this task to go and get the .net website. I've got a slash in there. And I've told it, here's what I want you to do after it, and I'm going to await that entire block. It's going to go get the data, it's going to continue with, and return when it's done. So when I run this now, you see it immediately comes back and says, not complete, right? Because I have that task and it's still out asynchronously running. I'm going to await it to complete, and when it completed, it wrote out true, and there's the length of the .net website. Let me show you again. Immediately comes back false, right? Instantaneous processing, because that's the next line. We're not awaiting, we're not blocking, we're not releasing the thread. Immediately come back, and that other process that's happening that we're waiting for eventually comes back, and we get true and the HTML length. So we're now chaining things on and continuing and specifying other things to happen as our processes happen. Complete, I'm sorry. Can use async await. Dave asks, can you use async await to spawn off a method to create a PDF, for example, and then let me know if it completed the task? We're going to see in just a little bit. That's a more CPU intensive thing, not IO intensive. And we'll use a structure like Task.run that we can await that task. Go create the PDF, let me know when it's done. And we will await that task that's running. So we're notified when it's done and we can continue processing. If it's not parallel, do you still need locking for thread safety? You do. You don't always need locking for thread safety. You need. It depends on what you're doing. But you're going to want to be careful so that things stay thread safe. Past instances of things, so you're dealing with instance variables of things. It's when you're dealing with statics that you're going to run into issues of thread safety. Yeah. Have I shown how async and wait implements the feature? No, I am not getting into implementation. That is way too complicated for what we're talking about. Can we use serialization? Serialization, Tony, absolutely does some asynchronous processing because it's CPU intensive. So we want to release control of that thread while we're working through here. How to decide when is efficient enough to use async methods in your new defined classes? Depends. If you're doing something that's IO bound, or CPU bound, that's when you're going to want to make that decision. If you're not, don't need to do it. Do I recommend using async methods as much as possible? Only a Sith speaks in absolutes. Isn't that what they said in that movie? I'm not going to recommend that you use them as much as possible. I'm going to recommend when it's appropriate, when you're interacting with another device, when you're interacting across the network, something that is I/O bound. I would recommend using an async method. You don't have to, but I would recommend it. We're going to talk about ConfigureAwait false, and I'm going to say no, it is not a good practice. What happens if I do 2 awaits after each other? They end up, just like we saw up here, they end up running, right? So I ran it here. They end up running synchronously, right? So there, it's cached now. And if I run 2 awaits right after each other, right? It ends up running them synchronously. So it takes longer because it runs the one, waits, runs the other. So that may be what you want, but if you want to get more out of this, get a little bit more speed out of it, there we go. You're going to want to run them in parallel, right? So that one kicks off and runs, then the other one kicks off and runs, and you wait for them both to complete and come back. Can I explain a use case? I'm going to get into ConfigureAwait. ConfigureAwait is very much misunderstood. And folks think that it is the answer to creating more speed in your system. And you can actually create a little bit of chaos going in there. Get await or get result in one-thread applications. Yes, I'm going to show you that in just a little bit. Tell us about deadlocks. I don't want to get into deadlocks too much. Is it bad to use async and await in .NET Core environment? No, not at all. We think it's terrific. To avoid thread starvation. Yeah, it handles that for you. Is this similar to how Concurrent? I don't know, Golang, I'm sorry. Can async processes utilize the benefit of multiple cores? Yes, absolutely. That's why you would want to do that. Why is ConfigureAwait? The questions about ConfigureAwait are strong. I promise you we're going to get to it. It is an advanced topic that the people who ask about it, quite frankly, you've been misled to think that it is a performance thing that you must do everywhere. It is not. We'll get to that in just a little bit, I promise you. We can force async methods to run synchronously. So we want to, we're inside of a synchronous method and we need to block. You can add on to the end, get a waiter, get result. Let's wrap that so it's a little bit easier to see here. Okay. When you do that, it says get the awaiter, get the thing, that pointer that's holding on to what's awaiting over there, and get the result when it's done. And that will hand off and allow things to process. The wait is the other method that you can use to make sure that things come back. And I'm blocking and waiting for them. There is no asynchronous processing happening there. Okay? I wanted to show the breakfast example next. This is an example from the .NET docs around how asynchronous processing is important and how it helps with how you build and interact with your code. So if we were making breakfast, I've got juice, toast, bacon, eggs, and coffee, and we've got some methods for how we prepare breakfast. We're going to pour orange juice. We're going to write out that we're pouring orange juice. We're going to apply jam to some toast, putting jam on the toast. Apply butter, putting butter on the toast. We're going to toast bread, and we're going to pass in some number of slices, and we're going to put slices of bread in the toaster. And we have to wait 3 seconds while it's toasting, right? And then remove the toast from the toaster. And, of course, return our toast. We're going to fry bacon, put a certain number of slices of bacon on the frying pan. We're going to wait for a certain number of seconds for the bacon to cook, and then we're going to flip it, cook the second side, wait a little bit, and then put bacon on a plate. And we're going to do the same thing with eggs. Warm up the egg pan, wait for it to warm up, crack eggs, cook eggs, wait for it, put the eggs on a plate. And pouring coffee just happens immediately. And these are all synchronous methods. It's way too slow if that's how you make your breakfast. If you first pour your coffee, then go fry eggs, then fry the bacon, then toast the bread. And when the bread's done toasting, apply the butter and jam, and then pour the orange juice. If you do it that way, you're pouring coffee. The coffee's ready, waiting for the egg pan, cracking the eggs, cooking the eggs. Eggs are done. Okay, putting the 3 slices of bacon in the pan, and my eggs are getting cold. Flipping a slice of bacon, cooking the second side, bacon's ready. Bread's in the toaster, toasting, remove toast. Finally, pour the orange juice, and breakfast is ready. But down here, at this point, my toast, my bacon, my eggs are all cold. So you want to do things a little bit more asynchronously. So if instead we toast bread asynchronously and we await while those 3 seconds are going on that the bread is in the toaster. While that's happening, yield the thread and go do something else, right? I put the bread in the toaster, push it down so the toast starts toasting. I can go start cooking my eggs instead of staring at the toaster and waiting for it to finish. Okay? Same thing over here with cooking the bacon. I'm going to await task delay. I'm waiting those 3 seconds. Well, yield the thread while it's there cooking. I can turn away and take the toast out of the toaster when it's done. Other things like that. Same thing with the eggs. I'm going to await task delay. Now, of course, in real code, right, it's not await task delay. Maybe it's writing a file to disk or calling a microservice or something. Interacting and calling an IoT device that has a servo, like in Doc Brown's lab, that's actually flipping the eggs or something, right? There's the Back to the Future reference for you, right? It's doing something behind the behind the scenes with some other piece of hardware. We're waiting for that thing to happen. For the purposes of this demo, just to make it a little bit clearer and simpler, I'm just awaiting for those. So now I can say, let's start off by pouring a cup of coffee, start frying our eggs, start frying our bacon, start toasting the bread, and await the toast. Wait for the toast to be done, because when it's done, I'm going to apply butter, apply jam, and then the toast is ready. Pour the orange juice. And now that I have my toast, my orange juice, and my coffee, well, let's wait for the eggs to be done and say eggs are ready. Wait for the bacon to be done and say bacon is ready, and then breakfast is ready. So now when I run this, look at this. Look at how much faster it's happening, right? Done, right? Yeah. Breakfast is ready. All done. So poured the coffee, warmed the egg pan, put the bacon in the pan. The first side of bacon was done. While the first side of bacon was done, it started toasting. When it was done, as it was toasting, we flipped the bacon, cracked the eggs while the second side of the bacon was cooking, cooked the eggs, removed the toast while the eggs were still cooking, buttered and jammed the toast. The toast was ready, poured the orange juice. Then we put the eggs on the plate. We put the bacon on the plate because the bacon is ready. So that's more like how we make breakfast. You're multitasking. Multiple things are going on, whether it's the pan on the stove, it's the toaster. We're waiting for these things to finish in order. Before I get to the discussion of ConfigureAwait, let me catch up on chat. We're going to talk about ConfigureAwait next, and I'm going to be brief, and we're going to get through this. That's right. Howard, it is a edge case, and we're going to talk about that. It does create interesting behavior, yes. ASP.NET, MVC, CRUD app, and Azure App Service with Azure SQL Database. Should database calls be asynchronous? Yes. Yes. Is when all needed at all? Yes. Just start the task without async, then one by one get the results. You don't know if they're going to get done at the same time or not. In the case of Bing and .NET, they're going to return pretty quickly, and they should return in order like that. But what if I go out to some website that might be taking a long time? What if I go out to Ticketmaster.com, right? I'm going to order tickets, or StubHub, and I'm saying, go search for tickets to, right, to the whatever concert, right? I'm trying to not show my age here. Right, I'm getting tickets to the Taylor Swift concert. That's for you, Christina Warren. I'm looking for those tickets. I'm doing a search. Well, searching for tickets for my favorite venue is going to take a little bit of time, where getting the content from Bing.com is going to return immediately, right? The search engine homepage is designed to come back in less than a half a second, where searching for tickets in my favorite seating area at my venue at Lincoln Financial Field, the football stadium here in Philadelphia, it's going to take a little bit. It might take 10, 15 seconds to search for and give me a list of tickets that I might be interested in. So it's not always going to run and come back at the same time. Certainly, Dev, you have a super air fryer, says 3D Polywraith. Nice. Can we wait for an event to happen rather than a fixed time? Well, that's what task when all says. Is task delay the same as thread sleep? Asks Amal. Yes, it is. Task delay it behaves the same, but behind the scenes it's different. Thread sleep says block the current thread for this amount of time. Task delay says come back to this thread, yield the thread, come back after this amount of time. It's asynchronous as well, where thread sleep pauses, it blocks the current thread for a certain amount of time. Yep, thank you for the links into the .NET docs. Do we have a link for this notebook? You can get the notebook. You can go out to github.com, CSharpFritz, C# with CSharpFritz, and it's inside the notebooks folder, and it's not on this branch just yet. It's on, oh shoot, it shouldn't be 0209, but there it is. Async await and multi-threading down there is where you're going to be able to find it, right there. So that'll be merged into the main branch when we finish today's session. Let me see, what else do we have here? Catching up with chat. Getting tickets to Crosby, Stills, Nash, and Young. See, even calling it CSNY, that's a lot. So, all right. Let's talk about ConfigureAwait. And this is something that I think folks have jumped into and said, and they've been told, all they heard was, this is faster, so use this everywhere. And that's not the case. In 99% of the scenarios, when you're building an application, you do not care about, you should not want to do anything with ConfigureAwait. I have a link down here in the notebook to this article from Stephen Taub called the ConfigureAwait FAQ. And Stephen Taub is the partner engineer leader of the Task Parallel library, the async await features. He knows the performance of .NET inside and out. And we're going to summarize what he talks about here. You can read this article to go in depth. It's linked in the notebook so that you can jump through and read this if you want to know the nitty-gritty about how all this works. But it gets into things like synchronization contexts that for this session are a little bit advanced for beginners. For you as a beginner that's building an application, whether it's a Windows Forms application, WPF, a console application, a Xamarin application that's running on iOS or Android, an ASP.NET website, a Blazor application, you shouldn't consider this. It's an advanced thing that 9 times out of 10 is not going to get you better performance. So, folks have been kind of tricked into this. You don't need to do this unless you know you need to do this. Okay? You're going to trick up your threads and it's going to be a little bit ugly. All right? Can I drop that link into chat? Can somebody grab that link from the notebook and drop it in there. devblogsmicrosoft.com/.net/ConfigureAwait-FAQ. And you can read that, okay? What ConfigureAwait does, I've gone through and I've given the disclaimer about it, but what it does, I mentioned async await comes back, it yields the thread, and it comes back when it's done and says, okay, I'm going to continue processing. ConfigureAwait has a Boolean parameter that it takes in that indicates whether it is required to resume on the current thread or if it can continue on a different thread. If you're building some large multi-threaded thing, that might be desirable to allow it to continue on another thread. When you're building that GUI application like Windows Forms or WPF that handles a control action, a button click or something like that, and you need to update the user interface because after you click the button, it committed an order, right? It charged a credit card, something like that happened asynchronously. You need to update the user interface on the same thread. ConfigureAwait is configured by default to come back to that same thread so that in your application, you're back on the same thread when the processing completed, and you can update the user interface appropriately. In web applications, you're going to want to return to the same thread in order to respond properly to the client. Think about it. The web server has many threads. Let's say it has 10 threads, just for the sake of discussing. And you're coming through on the first thread and you're making a request to the database. You're going to yield that thread for a little bit while you're waiting for the database to come back. If it came back and it didn't return to thread 1, but instead returned to thread 5, you're sending the response data to somebody else. That's wrong. That's bad. That's really bad. So you don't want to do ConfigureAwait false and allow things to come back on different threads when you're running in that application model. When you're building a framework, when you're building something that's a shared library that's going to be shared to other locations, to other applications, and you are taking control of the threading, and you are managing exactly where things pick up and continue processing. And that's an advanced topic that not many people do. Then you may want to do ConfigureAwait. And the .NET team has used ConfigureAwait appropriately throughout the base class library, throughout the runtime, so that you get the best performance for how you interact with your code. Let me continue scrolling through chat here a little bit. Thank you, Chris Jones and What's Up Baby, for sharing some links there. Appreciate that over on Twitch. Most of the time, ConfigureAwait is not needed. That's correct. You're going to be over optimizing on it, and where you think you might be getting better processing because you're just grabbing the next thread to work with, you might not be returning properly to what's called. So you do have access to old school stuff like mutexes are very much around, semaphores, absolutely, and you may want to use those when you're working with multi-threaded code. So let me show you. I have a method here, make eggs. And I'm going to display the current thread's managed thread ID. I'm going to delay 2 seconds, but I'm going to ConfigureAwait true. 2 seconds later, I'm done making eggs. Now show me the managed thread ID. And when I run that, it's on thread 4, and then it's on thread 87. Now, for the purposes of the notebook that I'm working in, that is okay. That's fine. It's updating and painting things and returning appropriately, right? But when you're in these other situations where you're inside of an event handler or you're inside of a managed thread around you, you don't want to return on different threads. You're going to run into issues. Is the thread a CPU or logical thread? See, that's one of the benefits that Async Await gives you. You don't know, and you don't really care because it's being handled by the framework for you. Visual Studio gives a warning when you use ConfigureAwait is not included. It's been a while since you tested this. You shouldn't be getting that when you're working in .NET Core or .NET 5, .NET 6. Great video from Brandon Minnick about using Async Await. Yep. When you're writing an online game. So there's Sebastian, there's a great point. Now you're doing something that is massively managing many threads when you're managing an online game. You're building a server. Now you've taken control of the threading, right? You're not just working inside of a framework like WinForms, WPF, or ASP.NET, or maybe Blazor. You have control of the threading at that point because you want to optimize for that, and you know and it can handle appropriately when data comes back, when it comes back on different threads. That's a time that, yes, you may want to do ConfigureAwait false. But for typical websites, web services, don't do it. You're going to create more problems than the performance you think you're going to help with. All right. So we talked about, these are pretty much I/O specific things. If you have to, and I should rename this. This should be CPU intensive tasks and Task.run. That's better. So we've got some processor intensive things that we need to do. We can call Task.run to throw it onto a task that's happening somewhere else and wait for it to come back. So it's similar to Task Factory Start New method, but does not return a task object. Instead, it returns a task object that represent the work that was queued. So you're queuing this up to be run on a thread pool somewhere else outside of the current thread. So check this out. I can have this method show thread info, and I'm going to console write line the current thread ID, some string and the current thread ID. So I'm going to start off with show thread info and just application. There it is. And then let's task run show thread info task, and we'll wait for that task that was run to be completed. Now, when I execute this, this is what I mean when I say it might be multi-threaded. It's going to optimize. It saw that I can get that done really quickly. I don't need another thread, so it reused and handed it off. Right? Now, if I put a where was it? I put a wait in here somewhere. Right? If I do task delay, and let's just delay 500 milliseconds and wait for that. Okay? Run that again. And now you see it comes back because it was a longer thread, right? Because it detected this is going to take a little bit longer. It went and put it on a different thread. Okay? Now they complete on the same time. You make me sad. This is going to... Nope. So that thread scheduling, you don't control when you task run. It's just going to go and do its thing and eventually come back, right? Now, it may happen on the same thread. It might not. That's part of the beauty of this is I don't care. Get done everything and bring it back to me appropriately. Did true false of ConfigureAwait stop having meaning in .NET Core? In ASP.NET Core, it does not have meaning. There is no synchronization context. So it's not a... It's not something that'll actually do anything. It's quite frankly ignored. DIB is a .NET Interactive notebook. So this is very similar to the Python notebooks, the Jupyter notebooks we were using, but it's a little bit more specific and has some .NET specific features in it. Now, Somebody was asking about long-running methods. Well, gosh, what happens if there's long-running methods? How do we handle that? And we're going to use something called a cancellation token. In the past, what I've done to get around to deal with long-running methods is I've created a Boolean flag somewhere and set to false, and I say, while this is not false, or while it's true, go do these things and come back. We're going to use a cancellation token that's a little bit better structured for that, a little bit more thread safe, that we can cancel and it'll interact appropriately with our task, and we can listen for that cancel state and behave appropriately. I see a couple more comments coming through on chat. Let me catch up over here. So I'm saying not to use task in the implementation of promises. In the implementation of promises. One Punch Mac, I'm not sure I follow. What about Mono in .NET 6? Will that still have synchronization context? I don't know. I'm not familiar with how Mono is implemented. I'm sorry. I'm not going to be able to answer that. All right. So cancellation token, let's go back to that task run. So let's do something here that's a little bit unsafe. I've got a couple using statements so I can get my cancellation token source. You see it right up there. Okay, so the cancellation token source is it's a source object that generates the token and communicates to everybody that's listening to the token the current state of it. Okay, so I'm going to task run, and while the token is not in a canceled state, okay, so while the token is marked as continue running, and I grab the token right here on line 5, I'm going to say wait 1 second. When it is canceled and it exits this while loop, we're going to display task completed, and I marked it with inner, so you know that this is the statement coming from inside this. Now, the task run, I passed in the token as a second argument. This is so that the task knows I'm listening to this thing for cancellation. If it's been canceled before the task has been started, it won't actually start, which sounds kind of weird, because you can write this can be created as a task, and it may not actually be started yet. So I'm then going to task delay for 5 seconds, and then say cancel. Call the token and say stop running, and then I'm going to display task is canceled. Now, keen eyes will see the problem with what's happening here. When task cancel is called here, it flips the state of it, and it may not necessarily complete if we're still waiting this 1 second. If we're waiting this 1 second while it's been canceled, it's not going to receive that signal immediately, and it's not going to immediately stop. So if the task is still running, I need to stop it. I need to tell it stop. So I tried doing the Task.wait, and no, it gets away, and it actually ran out of control on this machine. So what I've done is I've put a source dispose down here that says stop, right? I should be able to do, like, right, where'd it go? T.wait to ensure that it's done. And now when I run it, you'll see I start getting some stars. And I waited my 5 seconds. Task is not canceled. Task is completed. Task is now complete. That's here because I've inspected the task and I know it finished running. So I'm running this long running process. And let me shorten this. Now that you've seen it runs for a little bit, let me shorten this. Okay. So it outputs all my stars. Task is completed. All right. Now, if I didn't do that wait there, it could actually exit out of this and still be running. I need to stop it because I've been processing, continuing, while it hasn't come back and finished. It hit the while here, all right? Does that make sense? Let me catch up on chat here before I move some of this around and you see what's going on. Yes, the notebook. I shared the link to the C# with CSharpFritz, and you'll see the notebook is right now. It's in its own branch over here, 0209, that you're going to be able to reach into, and it's right there. I'll tell you what, I'll just merge it right now. So it's right on the root, and then I'll update it. Why didn't it give me new pull request? From there, do it, create it, and merge it. There you go. All right. So now you'll find it right on the root in Notebooks 0209, so you can get it. All right. Let's see. Can't you just pass the cancellation token in task delay? So if I pass the cancellation token here, right? You know what? That might have. That triggers a cancel on the inside. So check this out. That cancels this, which then ripples up and cancels this task. So now I get the indication that it was canceled. It's complete, but it was canceled. It may have been completed correctly. So you're right. You're right. And that's another good way to solve that. Let me take this down so it's nice and short. Right? So you can pass that token into all of the tasks, and I forgot about putting that in there and describing it, so that it does trigger the cancel and stop the task immediately. Without that being passed in there, I'm really just waiting on the cancellation right there. But while you're triggering and running other external things, you can always pass a cancellation token. So while you're getting data from a database or making that HTTP client request, you can pass your cancellation token like this. And if for some reason it was canceled, application was stopped, some error somewhere else fired, and you're in a bad state, you can signal that token, cancel, and everything will stop processing. Good point. Thank you so much. Yeah. Yep. Normally, cancellation token is passed as a parameter. Closed browser. That's another good example, Burger B. Yep. Yep. If it is a long-running process, it is a good process. A good practice to pass the tokens. You're right. Over on Twitch, on YouTube, Howard mentions that. Yes. I'm going to get done a little bit early this time. So, what if I want to explicitly run a series of tasks in parallel for a collection? We normally have a for loop for that. Well, we have a parallel object that we can execute a for each method on it and say, for each one of these things, run it in parallel. So we can say parallel.forEach, specify the collection, and then the method to call. It's not a typical for loop statement. It's a little bit different because you're running this concurrently for each loop. Let me show you. So we have this sample. It's the prime number example from the Microsoft Docs. I've copied it in here. And there's a method here is prime that has the formula to determine if we have a prime number. Okay? Scrolling down, we're going to get prime numbers synchronously by just saying get the prime list for the passed in list of numbers. Let's do that, make it easier to read. And we're just going to say take the numbers where it is prime, cast it to list. Done. There it is. It's going to just do a loop across those and return the list of prime numbers. I can also run that in parallel. I just wrote a little variable here. Prime numbers is a concurrent bag. We're going to get, this is a concurrent collection that we're going to be able to insert into of the prime numbers that we're going to discover. I put a little display here to show, well, here's the number of processors on this machine. My number will be different, probably will be different from your number when I run this, okay? And I'm going to create some parallel options here, and I'm going to say max degrees of parallelism. How many parallel threads are we going to allow to run this? Well, I'm going to say the processor count. Let's wrap that again. I need to think of wrapping this when I create these things. Make it easier to see when I got this guy standing over here next to it. So run just the number of processors that we have. And here's the parallel for each. For each of the numbers that are passed in, use the parallel options, max degrees of parallelism, the number of processors in this case. And we're going to take each one of the numbers in that collection as we go across the loop. So here's the input and the method we're going to call. If it is prime, insert it into the prime numbers collection. Done. Return that collection of prime numbers. So I'm going to say, give me 2 million, up to 2 million, enumerable.range. Give me the numbers from 0 to 2 million as a list. Start a stopwatch and go get the prime numbers using the synchronous method, okay? Then we're going to do the same thing, create a stopwatch. We're going to run in parallel. Stop the stopwatch and display a little report here, classic, for each loop, parallel for each loop. And when we run this, on this machine, I have 16 processors, 16 cores, okay? On the regular for each loop, we found 148,000 prime numbers, and it took 800 milliseconds. Doing it in parallel with my 16 processors took 110 milliseconds. An 8x speed up because I did it in parallel. Now, I specifically put that option here, max degrees of parallelism, to show you, well, if I make it, let's just say 2. Just go to 2. Run it again. You see it speeds up roughly by 50%. Roughly. And there's, of course, diminishing returns on that as we ramp up that number. If we go to 4, a little bit less than 4x faster, and so on and so forth. Right? If we take that to 8. Right? Not quite. A little bit less. And of course, if I let it go with the entire number of processors. So we didn't get too much more out of it when we went to the 9th, 10th, and 11th processor. But using that environment processor count is an appropriate limit to how many you want to pass through. Sure, I could say run it on 100. It doesn't add anything more because now you're scheduling threads on processors. You're backing up, okay? You're not going to end up getting any more parallel capabilities. So realistically, the maximum number of parallel threads you want is the number of processors on your machine. Let me take a look back here at chat, catch up here. Can we create a UI to manage running processes and cancellations? That's what Task Manager is. But yes, sure. Absolutely. You can put all of those tasks into a collection and inspect and report the state of those. Absolutely. Is that var limit 2 million result an int? Yes. So, Mega Mr. Marlboro asking about that 2 million syntax that I used here. So this is actually making use of, I think it's a C#7 feature, where you can use underscores right there to delimit the size of your number. They're ignored by the by the C# compiler. Putting the underscores in there is something to help our human eyes be able to read the number and be able to identify, oh, 2 million. You may structure that differently. You may use whatever annotation you want within however many digits you want when you're declaring a number. Same thing goes with binary, right? I may want to put it every 4 characters in a binary number so that I have those grouped together as 2 bytes in a binary number, okay? So, continuing on here. Can I give a real case scenario in web development where parallelism could be applied? Sure, great example. Great example. I'm building a website that shows a dashboard of data, and I want to get all the data for the dashboard at the same time and deliver one package of data when that service is complete. So I'm going to asynchronously request from all those different places that I need data for my dashboard, task when all, wait for all that to complete, and then transmit. I could be doing a parallel for each if there was a collection of data that I want to inspect all of and return all of that as one block. Now, there was a question earlier about using async await in the middle of the parallel for each. There is, starting with C#9, the ability to do for each async. You can do it. It's a little bit dangerous and a little dubious to have async methods that are running on a background thread that are returning to a thread, and it can get confusing quick. So, fair warning: doing async calls in the middle of a parallel for each, can get tricky, and you can confuse things in our human minds of how it should process. Oh, loving that coffee today. I've got about a little bit less than 10 minutes to go here. Taking a look at chat. Web apps that process an image. That's another great example. Yep. Can't get done early on async. I know, John. Right? So much going on here. And I finally found the deck of cards that I meant to show when we were talking about collections. Instead, I was using magic cards. I had this deck of regular playing cards I meant to use. Look at that. These are from how far back in the day? James Way. Oh my gosh. Look how yellow it is. Oh my goodness. So, all right. I believe that's all I had for today's notebook. Let me take a look at chat, see if there's anything else that we want to catch up on. Threading allows you to shoot all 6 of your feet in one operation. Yeah. Can parallelism be used with Entity Framework to process data such as retrieving from a CSV before finally saving to the database? Saving to the database. Using an Entity Framework context, you see this with other interactions with the database. If you try to update the database in parallel like that, Entity Framework will block you from trying to do multiple save asyncs with the same context, with the same instance of a database context. We haven't talked about Entity Framework yet, so I'm getting a little bit ahead of myself. An Entity Framework context is a way that you make a connection to the database. So let's think about that as the connection to the database. If you make several save calls at the same time to the same collection through the same table, through that same database context, that database connection, and I'm simplifying, it's not necessarily a connection, but for the purposes of discussion, let's think of it as a connection. You can confuse Entity Framework and it'll block you from making multiple concurrent save requests, and the save being an update, an insert, or a delete. It'll block you from doing that at the same time because it needs to maintain state. So you need to queue those up and process them in the right order. Let's see here. You had a thread safety error when passing a DB context in parallel for each. Yep, there you go. That's right, Dave. Returning spatial results with yield. What? Can we use parallel for each to work with downloads, for example? Yes. You could do parallel for each to go out and I'm trying to suggest something that's not that's not illegal. And I keep coming back to the scripts that he wrote at the beginning of The Social Network. If you've seen The Social Network, you know what I'm talking about. But parallel for each could do that. Yes. Running parallel for each to hit a bunch of or to update, to notify a bunch of microservices. Hey, this event happened. Parallel for each across the microservice destinations that are scattered across a half dozen data centers. Go notify all of them at the same time. That's a great example of doing something like that instead of the Social Network movie. You watch because I talk with my hands. All right. I don't know. Yeah, websites. No, not website scraping. It's possible, but I don't want to encourage that. Why do we use double locking while implementing real life use cases? Double locking is used to ensure that that when you come in and make that second, when you're the second request to hit the lock, that the process you're looking to complete wasn't already completed. Hacking in movies is so terrible, says Drake over on Twitch. Totally agree with you. All right, we are just about out of time. I'm going to head over to the main desk, and let's call this a stream. Let's call this a stream. I got done a little bit early, but I think we answered some good questions. Headed back over. Oh, man. Feels good to be back. Hey, NetJam Jr. Thank you. Does Task.Wait block the calling thread? Oh, that was from way earlier, wasn't it? Yeah. All right. I think we got it. I think we covered everything we wanted to today on this. It's a lot to cover, and that was really for beginners, right? I want to make sure that that's clear. This was there are many different facets to multi-threading, async, and await. And for folks that are beginning, that are just dipping their toe into it, I don't want you to be confused. I don't want you to be overwhelmed. I want you to understand and appreciate that this is a very powerful tool that you can use to make your applications faster. Other things, right? There are people that like getting into the premature optimizations. Don't do it. Don't do it unless you explicitly know exactly how and why you're managing those threads. Because it's possible to get into a dangerous situation. For some reason, I lost my YouTube. There it is. There we go. Thank you so much, friends. I appreciate the kind words over here. As always, I'm right here on Mondays, 9 a.m. Eastern, what is that, 1300 UTC, answering questions, talking about cool C# features, and you're going to find me tomorrow, Tuesdays and Thursdays and Sundays, over on the CSharpFritz channel on Twitch, talking about Blazor and Azure and all kinds of cool stuff. Yeah, I'll see you tomorrow morning at 3D Polywraith. Thank you so much. Really appreciate it. So much knowledge leaking out of my mouth. You make it sound like I'm drooling there, man. Oh my goodness. All right, let's, those of you that are watching on Learn TV, thank you so much for watching. Hope you enjoy the next program coming up. If you're watching on YouTube, thank you so much for tuning in. Descriptions, links to the notebook just below me here so that you can find more, you can get all the samples, interact with them. Tell your friends, tell your families, tell your pets, tell your coworkers. Check it out. So much that you can do with this, and it's all in a notebook. It runs right there in Visual Studio Code, whether you're on Windows, Mac, Linux, or you even want to run it in the browser, right there on GitHub. Give it a shot. I covered that, Carlos. So sorry. You can go back to that. The notebook link, once again, if you are, and you're not, do I still have it here? No, let me grab it one more time. And you're going to look for, in the notebooks folder, you'll find, you'll find the Async Await multi-threading notebook in there. 0209 is what it's labeled. Thank you so much, everybody that's watching on YouTube. I hope you have a fantastic day. Enjoy the rest of the content on YouTube. We have a ton of .NET videos for you. There's going to be even more coming with .NET Conf in just a few weeks. I hope you tune in. You stick around for that. But for those of you on Twitch, it's time for a raid. Sorry, I will not be teaching WCF. We recommend folks move off of that. All right, let's take a look at who else is streaming on the big Twitch TV network. Figure out who we can get you connected with, who we can send you over to. Magic cards, that was previous time we did a little bit of that. Yep. I'm gonna get you connected with, who's this? I'm gonna get you connected with, you know what? We're gonna check out One Lion. They are moving a VB.NET Windows Forms application to Blazor. Let's get over, let's get connected to them, send a raid over, encourage, and hope you have a fantastic time. Hope you come back a little bit later on the Visual Studio channel right here on Twitch. You're going to find the docs team, .NET docs team, talking about some of the latest updates, some of the cool things that are coming, that you can find samples and learnings out there. And a little bit later, Mads Christensen will be back, and he'll be hosting Visual Studio office hours. That's all for me. My name is Jeff Fritz. I'll see you tomorrow on the CSharpFritz channel. Hope you have a fantastic day. Don't forget to sign up for .NET Conf, .NETconf.net. I'll see you.